Today I want to talk about the 3 most common reasons for failure when implementing CAN-based data communication in battery energy storage systems. Hey and welcome everybody, this is HMS Networks. Welcome to our channel. My name is Toby and today we'll take a close look at connectivity and network instability, communication problems and other internal or external influences. But before we start, you might want to have a look at our new white paper, which goes into much more depth of detail and will help you to take the right path and make the right decisions when designing CAN networks. You can find the download link below. With more than 35 years of experience in CAN technologies and as an expert in data communication architectures in battery energy storage systems, we have a lot to tell, and we think you will find this especially useful when you consider the rapidly growing importance of renewable energy and the ways to store it. We've certainly learned a lot when working with BESS integrators and communication system designers, and we are delighted to pass this knowledge and our extensive experience on to you. So let's have a look at the first reason for potential failure. Mistake number 1 covers incorrect cable routing and the use of unshielded, non-standard CAN cables with connectors that are unsuitable to connect the different battery cubes and devices within your BESS CAN network. It's very important to have a clean line topology. That means that the drop lines should be kept as short as possible to avoid signal reflections, and that will degrade signal quality and system reliability. When it comes to the actual cable, we recommend using shielded CAN cables with CAN high, CAN low and CAN ground. We recommend you using our standard CAN cables instead of buying cheaper ones in the internet. Use a twisted pair for both CAN high and CAN low. This minimizes the external electromagnetic influences. You must also consider the method of termination. The cables must be terminated at both ends with a 120 ohm resistor to avoid signal reflection, which will impact the signal quality. It's also important to ground the CAN shield at one side to avoid ground loops. The second and most common mistake is not considering the length of CAN bus. The maximum bus length depends on the baud rate. To give you an example, when operating the network with 500 kbits per second, the maximum length of the bus is limited to approximately 100 meters. If you need more, then there are only 3 options. First, you lower the baud rate. Second, you improve the cable routing by using repeaters and drop lines, or third, you expand the bus by using CAN bridges. We need to make a distinction here. CAN repeaters do not allow to extend the maximum length, but instead intelligent routing often saves cable length. You adapt the bus to the best system structure with drop lines. A CAN bridge is a real bus range extender. It divides the network into independent segments, allowing you to extend the bus system. When the use of repeaters and adapted cable routing are not enough, CAN bridges are the solution of your choice. I know it sounds complicated, but you can find out so much more by watching our equally informative video about CAN repeaters and CAN bridges. You can find the link for this video, of course, in the description below. The third thing you need to think about is protecting BESS network devices against electromagnetic disturbances and overvoltage, either from internal or external sources. Within BESS systems, communication buses and power cables are often in close proximity, so electromagnetic influences are hard to avoid. Inverters, drives and external events such as lightning strikes can cause high voltage peaks too, which must also be blocked. Otherwise, they can destroy components, leading to high repair costs and long downtime. But how can you protect your system? Galvanic isolation is the key here for you. This is achieved either by using devices that are already galvanically isolated with special interfaces, or by using repeaters or bridges with built-in galvanic isolation to divide the system into isolated subsegments. This protects BESS components from overvoltage and prevents electromagnetic influences from spreading across the entire network. But that's not all, ladies and gentlemen. The use of galvanic separation has a lot more advantages. I will explain you especially that in another video here in our channel. And I hope this video helps you to avoid common mistakes when networking your BESS system. If it was useful for you, please give us a like and subscribe to our channel. And don't forget to download the white paper, which is free of charge for you. You can find the download link in the description below, and we see us next time. Bye bye.